Well, my name is Brettschneider. I am a physical scientist and a climate scientist with the National Weather Service, the Alaska Region headquarters, just down the road there in Anchorage. I'm really excited to be here today. I'm going to give a presentation on climate and climate trends, but I want it to be kind of free-flowing and have the ability to encourage you all to stop me and ask questions. And really, from a bigger picture throughout the day, I'm really here. I mean, I'm going to maybe impart a little bit of knowledge and wisdom, but mainly I'm soaking in other things that I'm hearing. So I'm really excited to be here. And I've got until 11 or 12 o'clock. So again, we got time to talk and explore different things. I already heard some things about patterns and trends and timing and that kind of stuff. I'm happy to address any of that. So. Okay. So first thing I want to talk about is, I guess I should have start with what is weather, what is climate, but I want to first start with, we're actually pretty fortunate in this area, and we've got, for Alaska, a pretty dense network of weather and climate stations. Now, for our lower 48 folks, maybe this wouldn't seem very dense, but for Alaska, this is pretty good, right? So we've got, and I color-coded it, it's probably hard to read, but we're right here, we're the black dot here. We have some longer-term climate stations, cooperative stations, and the smaller black dots. And we've got some, beyond that, we've got some what are called snow-tell stations. That's from the USDA, NRCS, which the Climate Northwest Hub, Holly is part of. We've got a couple of snow-tell stations. We got up at Hatcher's Pass, right next to Kootenai Lake. And I think that's all in this scene. And we've got some.
There's a snow-tell right in like the middle of Farm Loop at Spring Creek Farm.
Oh, really?
That went in 2-3 years ago.
Okay.
4 years ago.
Yeah. Okay. So I don't have. I thought I checked. Oh, so when I checked, I looked at snow. I think I checked. Well, it wasn't snowboard yet. Anyway, I'll update this for next time. And there's a lot of them that's been going in the last few years. So thank you to the USDA for helping us out a lot. Now, from a climate point of view, we're going to need longer, years of data. But so right now, it's going to be more on the weather side of things. And we've got some DOT stations. We've got some RAWs, which are automated weather stations, which provide some warm season precipitation and temperatures. We've got citizen observation. So we've got this good mix of kind of real time. This is what's going on now, and even what happened last week. But then when we ask questions about patterns and trends, we really need those climate stations. And we're really fortunate here to have a good long-term record. Next. So the top is cut off. Oh, well. Let's go to the next one, and then we'll go back. Go to the next one. I'll come back to this slide. So I was actually, last time I was here was back in June. We were celebrating the Matanuska Experiment Farm 100 years of weather and climate data collection. So Jody's not in the room, but Jody, hats off to her. We had a whole celebration. Our regional director, Scott Lindsay, came out, and a number of folks from the National Weather Service. And it really is, you can't, you can do some climate, you can look at tree rings and you can look at other proxy data, but there's really no substitute for a thermometer and a wind gauge and a snowboard and a pan evaporation site. We can't make really kind of specific characterizations without that information. So really appreciative of what you guys have been doing here, collecting that data for so long. Can we go back? Okay, so what is weather? What is climate? Well, weather is really kind of short term, real time. What's the temperature like? What was it like last week? What was it, how long was the growing season? What's the relative humidity? Is it wet? Is it dry? Okay, those are kind of just real time. climate, now we're looking at long periods of time. You know, what does historical data look like? What are our trends doing? A summary, classification. Are we in a tundra climate? Are we in a, you know, Mediterranean climate, or whatever? So those are things that we look at over long periods of time. And I think most people feel pretty comfortable about this. But what is that time frame? Well, you know, every month the Climate Prediction Center puts out a climate forecast for the next month. So when I say climate, I'm not talking about just 100 years of data that's been collected right here. Climate might be what's been going on the last 10 years, or it might be what's going to happen next month or next year. So we really can think of climate in different time scales, but different directions, the arrow of time. We can look back, we can also look forward. So I guess go ahead, 2. So let's talk about 2022. So how did it start? Well, so here's some, in our CS, some snow water equivalent data taken at the end of April. So SWE snow water equivalents. These are generally high elevation, not always, but generally in the mountains, basically. I mean, we have one here in Anchorage, but that's on the hillside. And they're all basically in the blue dots. You know, maybe down here at Portage, you know, a stray yellow dot, but everything is blue. 150% of normal water locked in the snow. Now, one of the things that we're constantly dealing with this time of year is, what does this mean? So to the local producers here, what does it mean to you when it rolls around to May 1st, when you see, oh, there's a lot of snow still in the mountains, it's really wet, the ground's really, what does that mean to you? Is that good? Does that tell you anything? Is that something you're excited about, or like, oh no, it's just too wet? What does that mean to you guys? If anything, maybe it doesn't mean anything.
Fire suppression. I'm most happy when there's because I think, oh good, we won't have so many fires.
Okay.
Water table.
From production standpoint, like definitely impacts when you can get into the ground if it's wetter.
Yeah, so you know, and this is, you know, like say with fires, you know, one of the things with fires early in the season, you know, if the snow lingers a long time, if it's cool, that really helps the early season fire. Okay, but what happens at the end of April doesn't turns out tell you much about what happens with July fires. So there's a very kind of temporal relationship there. You know, I know in 2019, right? I saw a few slides. You know, 2019. Yeah, it was like the wettest or the warmest June, warmest July, warmest August. You know, at least in Anchorage, and then this really intense dry period in the summer, especially in July and August. I mean, if you look at an annual time series, 2019 is completely unremarkable. Yet it was an incredibly impactful drought because it didn't rain. It was supposed to rain. When we typically get a lot of rain, we got almost none. So that kind of temporal side of things is really matters. So how 2020? We started off really wet in the mountains. Okay, so next slide. And for example, the Independence Mine, the Hatches Pass snow water equivalent, you know, from basically the 1st of February to the middle of June, had the record most snow water equivalent. Lots of water locked up in that snow, way more than, you know, the typical, like double the amount once we get into the end of April.
Is that the weather station? I work for SnowTel. Is that the weather station or the snow course?
That is the station. It's not the snow course.
So this is something that we actually need to address. We moved the station. So it's in a place that collects a lot more snow now. And we actually want to, I want to like discontinue make it a new station.
Okay.
So although it was close to record, if you look at the actual snow course, we measured the same snow course, and that was measured since the 80s or something. Right. It was not totally record, but it was very close.
Yeah, see, that's great information. I had no clue about that.
And that's like our bad. That's something that we need to do because we have all these like climate comparisons and it's measuring two different things. So
And there's, again, thank you. There's a lot of stuff like that that is either buried in the metadata of a station or is not anywhere, is institutional knowledge in someone's brain that can be barriers to doing analysis. Anchorage has a long-term upward trend in snowfall and snow depth. Well, you also have to realize that the measurement location moved from the airport to a forested area off Sand Lake Road. Nothing nefarious. Just the FAA contractors at the airport were terrible at measuring snow. So the service said, well, we're just going to move it to our office. It's just close by. So we end up with this discontinuity, which really affects checking. But interesting. All right, next, please. So how do we do in precipitation? Well, we started off. So these charts start May 1st. Can't read the letters, and they run through September 30th. So we started off, and this is from Matanuska experiment. It's right here, and here is Anchorage Airport, and we actually this red line here that's normal, and the green line is what's observed. Okay, so we start off, especially for Anchorage, but also down here, not doing so hot on precipitation, although we're doing okay through kind of late June. But then we have this really basically no rain at all. These are 10-day long periods. So, almost a month with basically no rain at all here. At the time of the highest sun, maximum solar energy, really going to drive things out. In June, regionally, I don't have a chart for it, but since 1950 was the sunniest June on record. So no precipitation, maximum sunlight, maximum solar energy, maximum evaporation. Again, even worse in Anchorage, but on about July 8th, switch got flipped. Everything changed. And we got wet. Okay. Anchorage currently, it's the second wettest year on record. We'll probably finish the second wettest year on record. Over here, it's going to end up being a top 10 wettest year on record, most likely. I don't know where we're at the moment, but it's everything changed, and as far as patterns and periods of time, we typically will have these 2, 3, 4 week long periods, and then we'll shift, back again. But really, the upper level pattern in the atmosphere, it shifted about July 7th through 10th, and it stayed there all the way through September. So we ended up with this big Bering Sea low pressure, upper level low pressure that set up, and it just didn't move. And we had southwesterly flow, we had rain, we had clouds, and it just didn't stop. And there was nothing that shifted that. Now, from a climate point of view, we asked this question, we ask the question a lot, is this the new normal? And that's always a tough question to answer. From a theoretical point of view, we think the jet stream is slowing down. Anyway, are most people have at least heard the term jet stream? It's this kind of ribbon, fast-flowing jet of air that separates mid-latitude air masses from polar air masses. And the strength of that is mostly proportional to the difference in temperature between the poles and the equator. Well, the poles are warming a lot more than the equator is, so that temperature difference is less, so our jet stream moves a little bit slower. And that tends to, in theory, make the jet stream more susceptible to kind of large shifts in pattern, but those also become harder to dislodge. So we can have longer periods of dry, of wet, of warm, or cold, not as progressive and transient. So anyway, so dry, then wet. Here, in Anchorage, same thing, dry, then wet. Next. And this is a trace of growing degree days. So growing degree days is the accumulation of each day the temperature is above 50 degrees. That's just kind of a standard value. It has more meaning in some areas and maybe less meaningful in other areas. But 50 degrees basically where we warmer over than normal. And you can see really we were okay in May, but then just once we hit June, we got really warm. And we added a lot of positive growing degree day anomalies, right off the bat. And we increased that all through June. Same with Anchorage. Really, beginning of June, they started to really add up, and the differential really peaked in late July. But then these lines kind of get closer together through August. So August wasn't really as warm compared to normal. Again, largely a result of just rained a bunch. It was cloudy. We got less solar input. And so even though it was cold, right, it was a little closer, even below normal for stretches of time because of the rain, not because of a cold air mass movement, for example. So anyway, so we had this combination of early season, warm and dry, late season, not as warm, very wet. These are some plots I made, and it shows this is a ranking. It's an anomaly. This is a ranking. If you look at the May-June period, it's almost 100 years of data. Anything in this darkest color here is the driest May through June on record. Using this NCEI, National Center for Environmental Information, period. I made this map a few months ago. If I had made it today, I would have kind of zoomed in on South Central. But this whole area in underneath the label there was very, very. You don't need me to tell you that. This is really dry, but from a historical point of view, way here in these brown colors. So it was notably dry. Okay, now let's look at July, August, September. 3 months period. Okay, now look at the blue. Blue is wettest on record. Okay, we're basically all in blue here. Now, the way they make the data, they assemble the data, there can be a little bit of differences here and there, but it's basically at the top end of the scale. We start at the bottom end of the wet scale, which is the dry side, of course, and then we end up in the wet side. Okay, and so when you add all it together, that 5 month period, well, how do you classify it? Well, was it it becomes a real challenge to say, here was one number to characterize it. It was a little bit wetter than normal. So if I said, oh, this summer was a little bit wetter than normal, does that give you, what does that do for you? It doesn't do much for you. It was a summer of two halves. Okay. And of course, it was the summer of a drought. Okay, and drought is, well, this is the progression of the U.S. Drought Monitor maps, and we're going to learn more about the U.S. Drought Monitor maps and the process later. When we talk about, and not to put the cart in front of the horse, because we're going to talk a lot more about this, I'm sure. But what is drought in Alaska? That's part of why we're here. So I know the NIDIS enabling legislation has, there's agricultural and hydrological and ecological. There's all these different ways that we can characterize it. And what the drought for people in Southeast is different than the drought for South Central, which is different than the drought we think of drought in the interior. So everyone has their own flavor of that. But, starting in the middle of May, okay, the spring is our driest time of the year in most of Alaska. Okay, if we don't get any precipitation in March, no flags are raised, none. Okay, because that's not uncommon. Same with April. No precipitation in April, no big deal. It's not exactly typical, very, but not uncommon. So we're not, no red flags. May is a very dry month, but in May we started our upward. Well, we start our upward trend in precipitation in most of the mainland. So that's when we really start to say, well, okay, now let's start thinking about drought. Now, if I can put the cart behind the horse, do we think about drought in February? You guys get up in February and say, look around and say, no, I'm worried about drought. Yeah. Based on what you see, not about planning for resource allocations.
I mean, you like to ski and they're like, well, if there's no snow this year, or there was snow and it all melted and now it's all ice. That's what thinking about.
From a producer side.
Oh, from the producer side. No, not so.
Well, and that's something that like Rick and I have talked about. If you look at what the definition of drought is, it's a lack of precipitation that leads to impacts. Well, if you have no precipitation out here, and it's 25 below zero, maybe you have frozen pipes and frost heaves and stuff. That's a drought impact. And we've talked about, well, should we alert Holly and the drought monitor folks that
yes,
in January or February,
yes,
hey, we might be getting some frost heaves and whatever. So, and there's not a great answer to it.
no, there is a great answer. Yes,
Yeah.
because of the amount of time it takes to ramp up, and we'll get to that.
Okay.
We talk about the ag side
Right.
later in the USDA relief based on the drought monitor. So
There you go.
yes,
There's the answer. Okay, so May 17th, nothing. May 24th, now we're starting to paint. And let's just ignore the lower Yukon, lower Kuskokwim Delta. Let's just focus on our part of the state. Okay, now we start to paint in some yellow. Yellow is called D0. Yellow means abnormal dryness. Okay, we're not in drought. Abnormal dryness is not drought, by definition. Okay, May 31st. Okay, now we've started to include, and it's hard to see on the screen, a little clearer on the computer. So sorry about that. Okay. End of May, now we're actually putting in this first color of what's called D1. What is D1? Is it moderate drought?
moderate drought.
Okay, so now we've included moderate drought from about Talkeetna down to about Kenai and Milchik down here. Okay, June 7th, about the same. June 14th, it's hard to see, but we actually have a little now D2, which is, what is D2 drought classified as? Severe. So now we've gone from moderate to severe. D2, same, about June 28th. Now all of, again, it's hard to see on the screen. I apologize for that. From Talkeetna down to Kenai is now all D2 severe drought. This should say July 5th, not June 5th. Looks about the same. July 8th, 9th, 10th is when the faucet got turned to wet. Okay. And we're real careful about the pace that we change it at. I mean, if it rains a bunch, you're in drought and it rains a bunch one day, we don't say the drought's over. We need to see that those deficits are replenished, if you will. But by the time we get to July 19th, we've reduced the drought. We've now pared it back to abnormal dryness. And by July 26th, we've taken all the drought, all the dryness, all the drought out of South Central. Okay, so we go from basically in 2 months, we went from everything's great to everything's great. But in the middle, everything wasn't great. It was the opposite of great. And that's something, I think some agencies call it flash drought. Some call it rapid onset drought. Whatever you want to call it, that's what we get. And this, even though this was kind of particularly intense this year, this is typically how it happens here. We don't see the evolution of drought, over a 6-month period like they do in some other areas. It happens fast, and it can go away fast. Okay. Next, please. Okay, so now from a climate scientist point of view, we're saying, well, what can we look at? What can we put our magical hat on and say, well, what's driving this? What's influencing this? What can we look at to see if, well, where's this? What's the evolution of this going to be like? And right now we're in a La Nina. Most of you have probably heard about that. Who's heard that we're in a La Nina, or who's heard of La Nina? Everybody, every hands up. Great. So that's a cooling of the ocean surface waters in the central tropical Pacific. What does that have to do with Alaska, right? Well, it turns out that that's a good proxy representation of what happens to the big, massive tropical thunderstorms that form in the Pacific Ocean. And where those form, as the air rises and spreads out, it affects circulation patterns over a hemisphere. And in La Nina, that happens further to the west, further toward Asia. And that means the air masses are the air where the air sinks and moves and rises, and when it does all that stuff, it happens further to the west. And that affects where high pressures and low pressures set up that affect Alaska in the lower 48 mid-latitudes. So currently, OND stands for October, November, December. 100% chance that we're still in La Nina. Third year in a row for La Nina. NDJ is November, December, January. Blooming's is probability of La Nina. And so the current thinking is La Nina is on the way out, but it's still the most likely, it's still more likely than the opposite, an El Nino, or nothing, or several more months. There's really not a lot of likelihood of anything beyond that. So this is the third La Nina winter coming up in a row. That's only happened a few times before. Now, last year's, if I was here a year ago today, and I said, what's the latest? If I put a 21 version, it would look almost exactly the same. The thinking was that La Nina would fade out, and neutral conditions, and maybe even the chance of El Nino would creep in. That didn't happen. Okay, so here we are. These things are really hard to predict. We only have kind of a partial grasp on how that part of the system evolves. Next. So I'm not going to get too much into the weeds on statistics, but this is kind of a statistical relationship, all 4 seasons, to how we respond in Alaska to La Nina, El Nino. And the colors range from green to purple. Well, there's only green on here. These mean there's a positive relationship. So if those waters in the Central Pacific are warm, we're warm. If they're cold, we're cold. That's the positive relationship. Basically in all the seasons. Okay. So right now, those waters are cool. So we would expect cooler winter, cooler spring, cooler summer. So we kind of run on average in lockstep with that, but not always. Okay. On balance, we do. So El Nino, La Nina, it can explain 40 or so percent of our climate variability. Well, 40% is not 100%. It's 40%. And so there's a lot of other stuff that goes in there. And on the precipitation side, now you got the other colors. Okay, so now this is the relationship between those ocean temperatures in the Central Pacific and our precipitation. And purple means it's the opposite. So if it's warm temperatures on the ocean temperature, our high temperatures, we get low precipitation. Low temperatures, which would be like La Nina, higher precipitation. Okay, so we're kind of on the border here. So winter is kind of not really a big signal, but for summer La Ninas, so cool, low temperatures, more precipitation. So I was telling people in June, when we were getting no rain at all, I said, just so you know, typically La Nina summers are wet. And people are like, yeah, well, that's just not working out this year. Well, it did work out this year. So, it just got a late start. Same In the fall, though, those cool temperatures typically lead to the opposite. Low temperature, positive. So low temperatures, lower precipitation values. That part didn't work out so well. Although, we kind of split the difference on when it got rain the last part of summer and the first part of fall. So that kind of complicates things. Next. Okay, so this chart, it's a little hard to read this. This is the first last freeze date. Did you know that right here, they had their latest first freeze on record? Okay, October 10th. Okay, well, typically, the year before it was in hard freeze in late September. And typically it's in, the third week of September here, but not this year, October 10th. So, and if I put a trend line on here, our first freeze is getting later. And our last freeze in the spring is getting earlier. So that's our growing season. Now, the first freeze, last freeze, that matters more to some agricultural, silvicultural products than others. If you're growing flowers, maybe that matters more than if you're growing a potato. I don't know which products are more sensitive to that than others, but in general, the growing season is increasing in length. Okay, so let's look at temperature trends. And the temperature trends, well, they're not our friend. Well, let me take that back. So if you like having a longer growing season, then maybe the temperature trend is your friend. But this has other impacts on drying out soils, the frequency of wildfires, the ability for invasive pests to come in. Okay, so changing of the temperatures, matters a lot. And Rick Tillman made this graphic. I'll credit Rick. I don't know if Rick's listening. So anything in red is increasing temperatures, and well, look at the scale. We really don't even have a blue side of the scale. Okay. So if you're looking for, well, where's temperatures decreasing? Well, they're not. I think there's some small areas like around Haines, in southeast. Maybe it's just grab a microscope, slight cooling trend in some seasons, but that's an error. That's a rounding error in terms of its statistical significance. But summer, now the heart of the growing season, not a lot of warming. Most of the warming is in the rest of the season. And that's largely to do with sea ice and snow cover, right? Even 100 years ago, there was never any snow around here in the summer, right? So the energy balance part of the equation where snow is reflecting sunlight, or if there's no snow, it's absorbing it. That part of the equation is not any different than it was 50 years ago, 100 years ago. But that's a big part of the equation now, and in all the other seasons. Is there snow on the ground on November 16th? Well, there used to be snow on the ground most years on November 16th. Now it's not guaranteed. So when you take that snow out of the equation, now that's in November, there's not a lot of solar energy. But let's talk, the end of October, where there still is some solar energy. Have snow versus not snow, that drastically affects your energy equation. And same with sea ice. Okay, so every season is warming, and here in the valley, winter is warming the most, but we've got orange here in the fall and the spring as well. And then Rick also put this together, changes in April snowpack. So April as the proxy for how the overall season did. And we see some browns down here in South Central for 30+% decrease in April snowpack. We're still kind of in the gray here. So we're plus or minus 10%. So we're hanging in there with snowpack. But what this doesn't show is the snow season is squeezing. It's getting shorter. Now, for now, we're okay because the core winter months are accumulating actually even a little bit more snowfall in a lot of places. So December is a little snowier. January is a little snowier. So that kind of masks the fact that our snow season is trending, is squeezing. Now that can only go on for so long, right? I like to give the example, who gets more snow, Boston or Atlanta? The answer is, well, Boston. Well, why is that? Well, of course. Why is that? Well, Atlanta gets less snow because it's warmer there. So eventually, the laws of thermodynamics will catch up with you. When it warms up, you get less snow, period. Okay? Right now in December, if you warm up from 23 to 27, that doesn't affect your snow. Actually, that actually can get you a little bit more snow in some cases. But if you warm up from 30 to 35, well, now you're transitioning a lot of that snow to rain. Okay? And that has lots of impacts for when that snow melts out, which affects the flow in the rivers, which affects the water table, where the ability to pump water out of the groundwater and so on. How about summer rainfall? Okay, summer rainfall trend is on the rise. Everywhere here is shaded in green, maybe a little bit of gray for not much change, but we're in the green zone here. We're on the at least 15% increase. Now this is from what's called a reanalysis product. This isn't from rain gauges per se, but it's broadly representative of the trends. It's a pretty good data set. So we're getting wetter. Now we have this paradox in the summer where we can be wetter and drier at the same time. Well, how does that happen? Well, that means maybe your number of days per year with rain stays about the same. When it does rain, it rains harder. But when it doesn't rain, because it's warmer, the soils can dry out faster. So you can have this. It seems like a paradox, but when you think about it, it makes sense. So more rain when it does rain, drier when it doesn't rain. And because we can have these patterns that last longer, now when you have a dry pattern, now it can be longer in time period, and each part of that time period is more intense. So you can have highly impactful droughts, more impactful droughts in a warming, wetter world. So now just a couple of time series that I pulled together. Annual trend in summer surface temperatures, and I selected the point right over Palmer, the lower part of the valley here. And there's not a trend series line here, but as you can see, things are getting warmer. We're trending upward. There's a lot more red on the right. Well, here there's only one red bar, in the first 30 years of this period. This is since 1950 through into 2022, through 2022, because it's summer only. Lots of red dots over here and only a couple of blue. Now, as a proxy for moisture, this is what's called the dew point temperature. Sometimes you'll see that on the news if you watch Jackie, whoever, on the nightly newscast. Dew point is an absolute measure of moisture in the atmosphere. Again, only a few red dots here, lots of red over here. So an increase in atmospheric moisture. And typically when there's an increase in atmospheric moisture, we have an increase in that moisture being squeezed out as precipitation. This is a trend in summer precipitation anomaly. Again, summer precipitation can be wildly variable. So we have a lot more kind of deep blues here. It's hard to pick out a trend from the summer time series, but mainly I wanted to throw this on there to show lots of variability, lots of big wet years, but also some big dry years. And again, the blue means low. So in this case, blue means dry, not cold. I think I've got one more. Changes in summer cloud cover. So we would expect when there's more precipitation or we get stuck in a wet pattern more that there to be more clouds. It's hard to pick out a pattern, but it's one of these things where people ask me, or they'll say, hey, it seems like it's windier than it used to be. That's one thing. I kind of joke about this. No matter where you are, you're in Palmer, or you're in Fairbanks, or you're in Lincoln, or Miami, or Los Angeles. No matter where you are, a good rule of thumb is everyone says it's windier than it used to be. Everyone. There's no one, I've never met someone who says it's less windy than it used to be. Never. And I didn't put a chart on here, but the data doesn't really bear that out. There's really no trend in windiness, less windiness. In cloud cover, again, not much of a trend because we see these long patterns where we can be warm and sunny for a long period of time or really wet and cloudy for long periods of time, and not really much of a trend in summer cloudiness. This year, some of the last couple of years, this means less clouds. So here's 2019, right? It was just dry and sunny all the time. And this year, we kind of, like I said a few minutes ago, it's a little bit tricky this year because half of the summer was one climate regime and half was another. And so when you kind of average it all together, it kind of muddies the water, so to speak. But I've kind of run out of time. I don't know if there's any kind of question, but we should table that for the next session. I think that's my last slide. So any questions about anything climate-wise? Yes.
I'm really interested in Matanuska Valley because that's where I live.
Right.
Your snowtail sites over there, are they all at high elevation? Are there any at the valley floor? Because the patterns that hit us when they come from the Prince William Sound side, they kind of chug over the Chugach and hit high up on the Talkeetnas and they don't reach the floor.
Right.
So be kind of, is anything already captured?
I'm gonna pass it over here. From a snowtail point of view, over the years, when Turnagain Pass snowtail is having a big snow year, Hatchet Pass is having a lousy, and the opposite usually. It's uncommon for them to both be in the same. They're both a lot of snow, or they're both really low snow. So, but yes, I agree.
Could have like a good water table, but really dry soil.
Right.
The conditions that can drive that.
Awesome. Do we have any low elevation snowtails?
Yeah, so the one at there's one right on Farm Loop in Palmer. That's at Spring Creek Farm. Where are you located?
Actually, Chickaloon.
In Chickaloon.
Yeah.
Okay. Yeah. So I would say that the pattern that Farm Loop would experience would be somewhat similar, but maybe a little bit diminished to Chickaloon. Not quite as dry. It's pretty dry, downsloped from all of that moisture that you're talking about that comes into Prince William Sound. But yeah, to what Brian was saying, usually when things are hitting Prince William Sound pretty hard, all of that moisture gets squeezed out into the Chugach, which is why there's so many glaciers. And then it's totally, all that moisture is kind of been squeezed out by the time it gets into the Matanuska Valley. And then the Talkeetnas and the valley don't get much precip, but they do get a lot of wind.
Yeah, one time for that word ceremony back in June, I tried to look through all the cooperative forms for the Matanuska. There's a couple of Matanuska to see, how many times it indicated high winds, and I quickly just had to stop because there's so many notations for wind, high wind, lots of wind. But and sometimes there's a notation for a Knik wind, sometimes for a Nat Valley wind. It was too much to keep track of. Yeah.
I was just going to, maybe you could point on this map to the long-term recent records. They're actually not.
So long-term precip records, no. I mean, even our snowtail sites I don't think we have 30 years of data. Now, it's 30 years long-term. Not really. As far as long-term, I think Palmer Job Corps and right here. That's what we got for long-term. So we're drawing all of our conclusions based on basically, just a couple of data points that are pretty close to each other. And as you know, being out here, what happens here isn't always the same as what's going on in Anchorage. Okay, and so we've got more coverage in Anchorage. And then up the road, we've got, Talkeetna. We've got some climate data for Wasilla, but it's there's a lot of breaks. It's pretty spotty. So, we do the best that we can, but, as you know, again, a lot of times what happens, here isn't really what's going on here or what's going on over here. All right. Well, thanks for everyone for letting me chat. And I think we got lunch coming.
Thank you. Thanks, Brian.